All right, good morning, everyone, and welcome to Space Tech Expo Day 2. We are Z-Mark Fluid Power, and thank you all for joining us today. I'm Lucy Chen, and I'm the marketing director here at Z-Mark, and we're very excited about the show this week. Today we have a very special training by our world-class engineering team on the best practices for specifying hydraulic power units in aerospace applications. So before we get started, I'm going to give you a quick background on Z-Mark, and then Chris Machuzik is going to go over the following items in the training. What is a hydraulic power unit and their applications, considerations to specifying power units, and hydraulic power unit options, and then we're going to go over a Q&A at the end of the training, which will also include the giveaways and raffle for today. So I want to let you know that we have fluid power resources for aerospace available on our webpage, zmark.com/spacetech. You can find resource guides, catalogs, more trainings, giveaways, virtual tools, and so much more. And we will have a raffle at the end of this training, but we will also have a grand prize raffle on Thursday, 11 a.m. So you can accumulate some entry points. If you have any questions at any time or comments throughout the presentation, please feel free to use the question and chat box on your left-hand side. Quick reminder, right after this training, we will be on a panel at one of the Space Tech Talks. The topic is testing in a time of new design. So please register to attend if you have not already for this very interesting panel. It's at 11 a.m., so it's right after this training, and we encourage you to participate and ask challenging questions throughout that panel. I also want you to know that we have trainings every morning during the Space Tech Expo. So they take place during the 30-minute breaks, which is consistently going to be at 10:30 every day until Thursday. So today we obviously have the training for the hydraulic power units, but tomorrow we are going over a specialized training on motion control for actuation in aerospace solutions. And then we will close off on Thursday with specifying electrohydraulic actuators for aerospace applications. You can register for these at zmark.com/aerospace, like I mentioned. And you can win some really amazing prizes, like we have a GoPro, a Qi wireless chargers, we have a lot of backpacks, vacuum insulated stainless steel water bottles, t-shirts, and so much more. Please also share with your colleagues. They will get a chance to win prizes and get an extra chance to win for referring them. They just need to enter your name at the end of the trainings. So we have a raffle at every training, including this one. And once again, just go on zmark.com/spacetech to get more details. So let me give you some background about who we are so you have an understanding of who's giving you this training today. So Z-Mark was established in 1976. We have over 40 years of successful experience in this industry. Z-Mark is a fluid power distributor providing industry-leading fluid power solutions like power units, cylinders, pumps, motors, valves, actuators, filters, fluid connectors, and so much more. We do have 4 locations across California, which includes Los Angeles, Oxnard, which is in the Ventura area, Fresno, and Hayward. We also have representation in Arizona to support anyone there. Los Angeles and Oxnard are our 2 Parker stores, and we do have a full operating hydraulic service center in Los Angeles and Fresno, and our test bench can actually support up to 100 horsepower. So we're here to support you with many of your needs. And I want to actually go over the fact that we are an authorized distributor and service center for Parker Hannifin, Enerpac, Lincoln SKF, Delta, MTS, and a lot of fluid power products that you may already recognize. We offer full service design, build, and repairs on a wide variety of power units, cylinders, pumps and motors, and fluid power solutions. And we definitely can support these systems with available inventory at our locations and partner stores. We can do quick hose assemblies as well at all our locations. It is just a nice service to have. And just a reminder, Z-Mark is a full line distributor for Parker. So we can help you with your full application instead of just a portion of it. And our engineering team is absolutely excellent at supporting interoperability in your system. So today we're focusing on hydraulic power units, or known as HPUs. And our engineering team is well known for their ability to assist with HPUs. They can assist you with some standard options, which Chris will go over, but we can also help you design and build a custom solution as well. So before we get started, we do have a poll, and we just have a few questions that we want to ask you. So let me pull it up right here, and you guys can just feel free to type in your answers to the first question, which is, what type of applications do you typically specify hydraulic components for? And it could be a variety of things. That's why it's not a multiple choice, but this will help us give us a better understanding of what we should focus on and not focus on, because every system can be different depending on the type of application or your specifications. So I'll give you guys like a few seconds to enter your answers here. Great, that is amazing. Okay, so we have another question before we get started. And the final question is, do you design fluid power systems in-house? So just go ahead and answer. It's a yes, a no, a not sure, but this will give us an idea of what type of system that we can do for you. Mm-hmm. All right, I'm seeing quite a bit of yeses, so that's excellent. No so far, so that's great. So we have all the right people on here. Okay, so here are the results of that poll. Okay, so thank you all for answering the questions. We're going to get started with our training here. And Chris Machuzik is our Z-Mark application engineer. He has quite a bit of experience going over trainings on different fluid power solutions. So Chris, go ahead and take it away.
All right, thank you, Lucia. And first off, wow, what a booming turnout we have here. My name is Chris. I'm the applications engineer at Z-Mark here in Los Angeles. And well, first off, I'm just going to answer the question, what is a hydraulic power unit? So hydraulic power units, otherwise known as HPUs, are one of the most essential parts of a hydraulic system, and that's because they produce the fluid power that the system utilizes. Think of it as the power plant of a hydraulic system. So each HPU has a pump, a motor or engine to drive the pump, a reservoir, as well as an assortment of accessories. These elements provide and control the flow for the system. So every hydraulic circuit of any type requires an HPU to provide fluid power. However, most applications that we work on, specifically in the aerospace industry, are units for powering load test stands for structural components, launch pad equipment and erectors, as well as general and specialized machining and manufacturing as well. So now what I want to do is I'm going to walk through a list of key considerations that we must address when designing an HPU. So HPUs are built based on the requirements of your application, which itself is dependent on the actuation used, be it motors, cylinders, rotary actuators, as well as their usage. How these actuators work in the system, this will determine the pressure and the flow rate required, and also how the system will be cycled. So first off is the pump. We're running a little bit slow and laggy there. There we go. So first off, the pump. Pumps provide the flow for the system. They are sized based off their displacement, which is just the amount of fluid moved by the pump in one revolution. And from here, we can calculate the flow rate output of the pump to be a function of its displacement and the speed at which it is operated, which you can see by this equation here, which is just those two in a conversion factor. Now, within this general context, there are two types of pumps, fixed displacement and variable displacement pumps. Fixed displacement pumps, well, they have a fixed displacement. The only way to change the flow rate of a fixed displacement pump is by changing its operating speed. Variable displacement pumps, on the other hand, have an adjustable displacement, which means that their flow can be changed independently from their operating speed. Now, while these are fairly basic descriptors, how exactly these types of pumps are integrated into a hydraulic circuit is a bit more involved. It's usually best just to leave that step with us. So, there's a pump. Now we have to move to what drives the pump, and that is the prime mover. The prime mover spins the pump and provides the required torque for the pump to generate pressure. Now, the most common prime movers are electric motors and combustion engines, but engines are a bit more involved to integrate. So, for the sake of this short presentation, I'm just going to dip straight into motors. So motors are selected based off of three things: their power, speed, and voltage slash input power. Now, the power is determined by the power draw of the pump, which we'll talk about in a little bit. And as for speed, 1800 RPM or 1750 or 1725 or whatnot, around there, is industry standard. But low and high speed motors are also available. And for systems where you need variable speed, variable frequency drives, known as VFDs, as well as things like gearboxes and power takeoffs, can also be used between the prime mover and the pump. For the voltage, you will need to know the electric power source available for your motor. If for most mobile applications or you're running off of portable batteries, usually you're running DC motors, so usually 12 or 24 volt DC motors. And if you're plugging this thing into a wall, you'll have, for example, 120 single phase, or a lot of places, most industrial facilities have 480 volt three phase available. This you'll need to know this information before you can select your motor as well. Now, going back to the power required by the pump, that determines the minimum power rating of the motor that drives it. This can be determined by this equation here. So, as you can see, as the pump's output flow rate and or the pressure increase, so does its power draw. And it also takes into consideration this conversion factor as well. Of course, there are mechanical and volumetric efficiencies in this energy conversion. So a pump will usually convert about 75 to 95% of its received shaft power into actual usable fluid power. The rest is rejected as heat. The efficiency of a pump can sometimes be found in this catalog, but almost always there is some kind of power curve chart that will show a more exact power requirement based on a number of operating parameters. All right, so that is the pump, that is the prime mover, specifically the motor. And now the last main essential component of an HPU is the reservoir. The reservoir houses the hydraulic fluid in the system. It separates air and large contaminants from the oil, and it facilitates thermal transfer to the environment as well. It rejects heat. Now, in order to fulfill these functions, the volume in gallons of the reservoir should be 3 to 4-ish times the flow rate through the reservoir in gallons per minute. So, for example, a reservoir that sees 10 GPM through it should be sized to 30 or 40 gallons or so. The bigger the reservoir, the more heat it can dissipate, but of course, the more volume it assumes. And if packaging is an issue, then integrating a heat exchanger into the system reduces the reservoir's heat dissipation demand, and so also might reduce its size as well. One thing to note is that large volume adders, these are things like single rod cylinders as well as accumulators. These require additional, well, breathing room, so to speak, in the reservoir. So if you have a large cylinder that displaces 5 gallons in its rod volume, you'll need to add that 5 gallons to the maximum capacity of the reservoir. So, generally speaking, there are three form factors of reservoirs. First one is vertical. These are named for the orientation of the pump, which is submerged vertically underneath the oil level inside of the reservoir. And as you can see, according to this picture here, the motor is mounted on the top lid of the reservoir. Excuse me. These systems are compact and they usually have a much lower risk of cavitation, and they're just packaged very neatly. They're very convenient when we can use them. Next type are horizontal reservoirs. Most common type is JIC or DIN reservoirs. Those are just the standard specifications. These allow for specialized mounting, such as overhead, which you see in this image right here. We usually use these in very custom applications for very specialized uses. And the last one is L-shaped reservoirs. Very much like horizontal, only they have a little shelf built into them, as you see in the picture. And these allow for greater heat dissipation and also provide additional mounting space for the rest of the system. The pump and prime mover, controls, and valving manifolds, and everything else that needs to go on there. All right, so those are the three main components, and there is a few other what we consider to be essential components in an HPU as well. First off is a system relief valve. This discharges the excess flow to limit the system's maximum operating pressure. Next is a check valve at the pump outlet. While not strictly required, this prevents back pressure on the pump, which can damage the pump and motor, and it's so dirt cheap that there's not much reason not to add it in every system anyway. Next off is a ball valve. Again, not really crucial, but a ball valve at the inlet to the pump between the pump and the reservoir eases maintenance and draining and such like that, and saves a lot of time in the long run. Next thing are return filters. These remove contaminants from the working fluid before it returns to the reservoir. This protects your components from damage and excess wear. And I have a little bit more about filters, but before that, I also just want to briefly bring up PLC. We also build PLC into most of our higher end HPUs to control the unit. For any of you who don't know, PLC is programmable logic controller, which is a simple input output microcontroller which can receive inputs from sensors, switches, and buttons and provide outputs to motors, heaters, valves, or really anything else that needs to be electronically controlled in the system. So, before I move on, I want to discuss a little bit more about filtration. One thing to keep in mind is that additional filtration may be needed depending on the environment and the application to increase the life and reliability of the system. This may require additional filters in different locations in the system, like you see in the schematic on the left-hand side here, or it may also require removal of finer sized particles as well. Sensitive equipment, such as proportional valves, for example, require upstream pressure rated filters with a higher level of filtration, to give an example. So, now we've gotten all of the essential stuff, and there's a few accessories that you can add to the HPU as well. And depending on the application, these may be deemed as necessary as well. So, in general, these are heat exchangers, instrumentation, accumulators, and manifolds. So, heat exchangers can be installed in systems, obviously, if there's a concern about the fluid temperatures. In general, these are broken down into coolers and heaters. Coolers are often used when HPU is in any situation where either large amounts of heat will be generated, or also when the unit is operated in very warm environments, such as outdoor desert test sites or launch pads at Vandenberg. It can get pretty toasty out here. Rule of thumb, very loose rule of thumb, is to size the cooler so that the heat removed is about a third of the power input to the system. But of course, in order to fully optimize it, every system is different, and we size a heat exchanger to every individual application. Now, heaters, on the other hand, are less commonly used, and they are placed in HPUs located in cold environments, or when the temperature and viscosity of the working fluid must be closely regulated. If you do want to do some extra reading on your own time, you can also find out more at zmark.com/thermal. So, next category of accessories is instrumentation, which is kind of a broad term that encompasses a number of things. First off on the list are sensors and gauges. These give feedback on the HPU for safety and maintenance and allows for troubleshooting the system, but it also allows for monitoring the system's operating parameters. Sometimes an operator will use it as feedback while they are manually controlling the system or whatnot. Next off, switches and transducers. Switches can be used for simple mechanical controls. Transducers, on the other hand, give digital feedback that can allow for more advanced computer control. The most common measurements for any of these things are for pressure, temperature, and reservoir oil level, but there's lots of different applications. Flow rate is another one. There's lots of different ways to measure flow rate, and position sensors and linear transducers and so on, but that's for another topic. So, next category of accessories is accumulators. Accumulators can be added into systems for many reasons, actually. Um, Most of the time, they can, for most applications, they absorb shock loads, and they can also provide backup fluid power in case of a momentary power loss as well. Additionally, an accumulator can also reduce the required size of a pump by supplementing fluid power in a low duty cycle application. Again, it gets pretty involved in sizing in and specifying an accumulator, so we'll just leave it at that for another discussion. And the last category of accessories is manifolds. Manifolds are very beneficial to applications with more than one actuator, multiple accessories, or really with any kind of complexity in general. They allow for higher flow rates and more compact and organized system setups. One of these manifolds can replace a dozen or more of hoses and pipes and tubes and whatnot. And also, if need be, we at ZMark are available to help with custom manifold solutions as well. Now, to summarize, when specifying a power unit, you want to make sure that you've taken into consideration all the factors you will need to size your pump, motor, and reservoir, as well as a rough idea of what type of accessories that you might need for your application. That way, when you approach a ZMark engineer like myself or Ian here, you will have a better idea of what you need to discuss in order to create the most efficient and cost-effective solution for your project. And now we're just going to switch a few things around here. There we are. And all right. So we've explained the generalized process through which we build a custom HPU to our customers' specifications and requirements. We can arrange these components to form different types of circuits that perform specialty functions or improve the efficiency of the system. Let me just make sure that... let's see. Oh, my bad. There we go. Much better. So, for low flow conventional applications, however, Parker also sells off the shelf units. These are their D pack, H pack, and V packs, like you see here, as well as their Oildyne compact units for more cost effective, small single actuator systems. So these power units, they're not actually quite off the shelf. in a literal sense, but rather they are built to order based on a small list of standard primary components as well as optional accessories. So when our customers do not have a specialized application or specific requirements, or they don't require very high flow rates, Parker's HPUs are packaged neatly. They require much, much less time to design and assemble, which means they arrive at your doorstep a lot faster. And they're also sometimes a lot more cost effective. Give me a second. I'm just having some technical issues with this here. There we go. All right. So, there we are. So Parker's online configurator also allows customers like yourselves to easily specify your own power unit. So let's actually run through the process of specifying a DPAC as an example. So first off, we'll start with the three basics, which is the pump, the motor, and the reservoir. For this, we'll need to know a required flow output and pressure rating from which we can determine our motor rating and reservoir size. So let's say that we require a flow output of 1.5 GPM at 1500 PSI as an example. We would then reference page 30 of this online catalog to determine which pump and motor are sufficient for this application. You can find the catalog through our website at zmark.com/HPU, and there's also a link to the configurator as well. But for the sake of this presentation, I've taken the liberty of copying and pasting that exact chart right here in the presentation. So we can see, according to this chart, that we will need in order to meet our 1.5 GPM requirement, we will need the 1.8 GPM pump right here to meet our minimum flow requirement. And if we follow that row to the right to the next step above 1500 PSI, we'll see that we need the 2 horsepower motor to provide the minimum power requirement for the pump. So now I'm going to switch gears here and actually show you the configurator on Parker's website. Let's see. And there we are. Hopefully you guys can all see that all right. So this is a configurator. If I am just on Parker's website for the DPAC, this right here in the big yellow button is configurator. And here it is right here. So first off, let's start from the top bottom. Reservoir. The DPAC makes it easy because there's only a 5-gallon reservoir available, so we'll skip that. Pressure control, let's say we only need a relief valve. Pump flow, there is that 1.8 GPM pump that we mentioned that's calculated at the 1750 RPM motor, I believe it is. And for the electric motor, 1725. Then there is that 2 horsepower motor. I mean, if you want, you can also order it without a motor and supply your own, but most of our customers purchase HPUs with the motor included. And let's say we only need a standard manifold here, and I'm going to stop it just a quick second. If we take a look up at the top here, you can see that as we are filling in all of these options and all these categories, that the configurator is slowly building up this model code. So by the end of this, we will have a finished model code. So let's go ahead and really quickly add all of our accessories. Let's say we're outside in the desert and we need a heat exchanger. So we'll just choose the one heat exchanger that's available, which might as well put a bypass in. That's always a safe option. And let's say we have proportional valves too. So we'll need a pressure filter, a check valve at the pump outlet's always a good idea. Return filter, you should always have a return filter. And a float temp switch, sure, why not? They're cheap. And now it's only, less than 10 options here. And here you have the model code for a fully specified configurator. I wish our job was this easy, but regardless, this makes it easy on you guys for your simple applications of HPUs. So all you need to do is just a second. Give this number to your to us at ZMark, and we will give you a quote the same day. And usually the lead times for these are much faster than if we were to design and build a custom power unit, which is always nice. So I am going to go ahead and skip out of this configurator. Hopefully that was fairly straightforward and easy to follow, and I will bump us right back to the presentation. Bear with me, we're almost to the end here. And there we are. Alrighty. So, just a reminder, ZMark Engineering, like Ian and myself, are here to support all of your needs, whether it be standard power units, like I just walked us through, or custom power units, which we design and build from the ground up, or any other fluid power solutions like custom manifolds and fatigue test stands and so on. To get started, just know vaguely what you want and then contact us. We will then review possible options for your application and get back to you with pertinent options and questions to move your project forward. Then we'll design a solution with optimal efficiency that can be delivered within the time frame that you need, hopefully. We take care of that heavy lifting while you go about the other things in your probably very busy day. So, congratulations, you made it all the way through the end of my spiel. Hopefully it wasn't too long and boring, and I will pass the torch back off to Lucy.
All right, thanks so much, Chris. So I just want to close off by reminding you that we do have trainings for tomorrow and Thursday. So attend yourself, have your friends attend, set up a meeting. If you want to talk about HPUs, find us on the Space Tech Expo platform, and you will get 5 extra entry points for the grand raffle on Thursday. So again, just go ahead and visit us at zmark.com/spacetech to register for anything there. We will take some questions. I believe I only see one right now. But if you like, we do have that live tech talk session going on right now. And just to let you know, the Space Tech website changed their platform. So if you're trying to join the tech talk, the link going to it directly may not pop up directly because they moved it to Zoom. But you should have gotten some kind of email about it. So just if you have any issues, you can reach out to me at zmark.com/chat, and I will pick up and I'll give you further instructions if needed. You can also email us at sales@zmark.com, and we'll make sure you get the assistance you need on hopping onto any of those talks. So the question I have here before I do the raffle is, do you offer a lot of replacement HPUs for existing applications? So does Ian or Chris want to hop on and answer this question?
Sure, this is Ian here. So yeah, we do. In fact, if you're replacing an existing unit, it's a pretty good time to maybe look at how that unit performed and see if there's any nice to haves that you might want to upgrade if you're going to replace a unit. I mean, we can always go out, see what you have, and give a direct replacement. If there's size constraints or whatever that we need to be aware of, that's not an issue. But if you are replacing an existing unit, sometimes it's a good time to think, and maybe that unit was getting hotter than you wanted, or maybe you need a little more speed on your actuators, just little things like that would have been nice to have. It's a good time to always consider that stuff.
Great. Thanks so much, Ian. So if there's no more questions, I don't see any here. Feel free to reach out to us if you have any additional questions. And I hope you have a great rest of your show. And feel free to join us for tomorrow morning's motion control for actuations in aerospace applications. Have a wonderful day and be safe out there.
Thanks, Lucy.
Thank you.